Let's look at some tough derivatives using the natural log and base e. So for number 12 here, we have ln of x to the 30th. Anytime we have ln of something, we're going to take the derivative of what's inside over the original inside. So I have a nice x to the 30th inside. I get to really not think about the ln. I can cover it up with my finger for a second. It tells me I'm going to take the derivative over original inside. So derivative of x to the 30th, I'm going to bring down that power, is 30x to the 29. The original inside is x to the 30th. And I'm done with that. I normally lift up my finger off the ln. Same exact thing for the next one. I have ln of e to the x. I'm going to cover up the ln and look at what's inside the ln. I'm going to do the derivative of the inside over the original inside. So the derivative of e to the x is e to the x over the original inside is e to the x. The next one is a little bit different. We don't have an ln, we have e to a power that's not just x. So I'm looking at this one and I know I'm going to take the derivative of the power times e to the original power. So I am going to give myself some space for the derivative of that power and then copy down e to the original power, e to the negative x to the 14th. So let's ignore that e for a second and just take the derivative of the power. The derivative is going to be negative 1 times 14 is negative 14. X to the new power is going to be 14 minus 1 is 13. So we took the derivative of just the power to be negative 14x to the 13 times e to the original power. Now let's combine those two rules. So for number 15, we have ln of e to the x to the 7th. I need to cover up the ln and think about derivative over original. Derivative of the inside over the original inside. So I can definitely ignore that ln for a second. It's not part of my derivative, but it tells me how to take the derivative. So I have the derivative of e to the x to the 7th over e to the x to the 7th. So I put the original inside at the bottom, and now I do have to think about the derivative of the inside. It's the same rule as this above. It's where we take the derivative of the power times e to the original power. So I'm going to leave some space, take the derivative of the power, copy down e to the original power. And I'm just going to look at the power and take the derivative of it. The derivative of x to the 7th would give me 7x to the 6th. So we did the derivative of what was inside by taking the derivative of the power. Derivative of x to the 7th is 7x to the 6th times e to the original power. And then in general, for all of these ln's, it is derivative of what is inside the ln over the original inside of the ln.